So, full term numbers, like it's the full term, I don't know how to like say that. Word I'm looking for.
What are our thoughts? What is this F of W, F of W right here?
What's the, isn't it the adding by one? And you're getting,
So adding the one, so for the inputs from, we're going from 0 to 1, so the input increases 1. And so if, for the outputs, we're going from 3 to 15, so what do you think F of W would equal? We're going from 3 to 15.
It would equal,
5. How'd you know that?
15 divided by 3.
Yeah, and so this F of W is the, y'all remember the whole factor? That's what that is, the whole factor, okay? So that's when we're going from 0 to 1, or a whole number of inputs, it's the whole factor. And so in this situation, it was 5, going from 3 to 15, like you said. Now, what is this F of C right here? Going on these
they're going from,
third steps.
they're going from 0 to 1/3.
It's going from 0 to 1/3, right? So it's 1/3 steps. So what did we multiply for that F of C?
1/3 of 5. I don't know what
What
it is.
is it?
See, it's 1/3 of 5.
Is it 1/3 of 5?
Yeah.
So let's think about that. 1/3 of 5, what does that mean? 'Cause that sounds like you're doing 5 divided by 3.
Would it be 5 cubed?
Close, not quite. What is this right here? Is that 5 cubed?
So that's 5 to the 3rd. No, that's
The cube root.
2
The
of 5.
cube root of 5. Okay, so 5 cubed looks like that, right?
Yeah.
5 to the 3. So the inverse of that is the cube root of 5. So how did we get the cube root of 5? Where did that come from?
The 5 into 3 parts.
5 into 3 parts. So right here, this whole factor is 5, right? So now we split that up into 3 parts. So how did that get us to the cube root of 5? Yeah, you're on the right track. We're close. So we have from 3 to 15, this whole factor was 5, right? And we know that it was split into these 3 parts. What is F's, the constant factor multiplied by the constant factor multiplied by the constant factor? What would this equal? Even if we don't know this number. FC cubed, or the constant factor cubed. Okay, so if we know that the constant factor cubed is equal to 5, could we solve for this constant factor? Right, so we have F constant factor cubed equals 5. So, like I just said, what's the inverse of this cube?
Cube root.
Cube root. Let me put it over here so I can make sure everyone can see. So we have this FC cubed equals 5, and you just told me that the inverse of that is the cube root. So that is cancels out the cube, so then you get the constant factor equals the cube root of 5. So that's how we saw, when we split this whole factor up into 3, that's how you could solve to see what that constant factor is. Now, one thing I want to note, I'm assuming no one knows what the cube root of 5 is off the top of their head. I know I don't. So, but when we calculated it, we have this right here, 1.70998. But then what is this symbol right here? Is that an equal sign? No, it looks kind of, it's like a curved equal sign, right? What do you think that means? Because we're saying it's not exactly equal to 1.70998. Why do you think that is? Any ideas? So I will tell you this symbol here means approximately. So that means it's just not exact. So what I want you to do, do they know how to do this on the calculator?
Y'all should. Y'all remember how to do cube roots?
Yeah.
So plug in the cube root of 5 into your calculator and tell me what you get.
What I will also point out, if you look, okay, before y'all do that really quickly, can you highlight in the middle on the bottom? You see where it says 3 times f sub c cubed? Yeah. So just circle all of that really quickly.
I got it.
Hold on.
No.
You're good. I just want y'all to see this. One, notice when I created this solution, did I just say f sub c cubed equals 5?
Nope.
No, I wrote an equation. Because where did you start? Where was this function starting?
3.
At 3, right? Then we were multiplying by f sub c 3 times to get 15. And so you get to the idea of f sub c equals 5. When I solved it, did I take a cube root in that middle step there?
Mm-hmm.
What did I do?
You talking about 15 or the 5?
The f sub c cubed, and then there's in orange a power to it.
Oh.
What did I do? Can you tell what that power is?
1/3.
It's okay. You can both get it right. Hey, Caroline, it's okay. So notice I raised it to the 1/3 power. Is that the same thing as taking the cube root?
Yeah.
Remember how we talked about rational exponents recently?
The denominator's the same
As the root, right? The denominator is the same as the root. So if you don't like doing a cube root in the calculator, you could just raise it to the 1/3, and that's way easier.
That is easier.
I will never put roots into calculators. I always do an exponent.
So has anyone put that into the calculator? Tell me what you get.
I got it.
You can either do
1.70998.
Hey, Caroline.
Is that it?
Mm-hmm. So I got
There's no other decimals after that?
No, there's not.
Oh, that just means, here, let me see real quick. It means it probably has like a float 5 or a float 6. Menu, nope. Doc, settings, document settings.
That was a number.
I know.
51, I can guess the numbers after.
Instead of guessing,
Here we
look
go.
at this.
Now tell me what it says.
Oh, God.
Yeah.
Hold on, give me a second to get here. Alright, tell me what it says.
1.70997594668.
Okay, so is this the same thing as 1.70998?
Yes.
Yes. I got a yes and a no.
It's a yes.
Yes?
You got a round.
Got a round. So when you round, is this the same exact number to that number?
Yes.
So let's look at what's
It's a 7 instead of an 8.
Let me ask it this way. If you round the number 8 by tens, what would you get to?
9.
If you're rounding it to the nearest 10, you would get 9.
I mean, 8. I mean, 7.
Hey, McKay, tell me a couple tens.
10, 20.
10, 20, 30, 40. So if I have the number 8, what's the nearest 10 it's going to round to?
10.
10, right? Is 8 and 10 the same?
No.
No. So that's kind of the same point we're saying here, is that although this is a little different than that, it's the same in the fact that we rounded right here, this 7 spot, it rounded to 8. So now we have this 1.70998. Now while those two numbers are close in value, they're not the exact same, which is why this approximately symbol is there to show that while this is close to the exact number, it's around. We rounded it to that number, so it's approximately the cube root of 5, or 5 to the 1/3 power. So are there any other questions about any of this? No? We understand? Okay. I forgot where I put the order.
That ain't there, I did.
I got you.
Oh, I found it, thank you. So, we'll talk about the objectives for 2.6, and then we'll get into 2.6, which is what I handed you as you were walking in or sitting at your desk. So, let's look at, can someone read me the first objective who did not read yesterday? Or I should ask, who did read objectives yesterday? Or did y'all?
I think Mr. Kenny read them.
Mr. Cam?
I might have sped through them.
Alright,
Thank you.
Cam, can you read me the first objective then? Good, so that's kind of what we've been looking at, is keep working with properties of exponents, which y'all are introduced to in the graphic organizer. Alright, okay, read me the second one.
The second one?
Second.
I can connect rational exponents to the roots of numbers.
Good, so that was actually a conversation we were just having about how can we look at a rational exponent and how does that correlate to the roots of the numbers. So, Caroline, read me the third one.
I can extend the properties of exponents to rational exponents.
Good. So now we're gonna start looking at 2.6, which like I said was that sheet that I handed you. So let's look at, before we break off and start talking about it in groups, let's look at number 1 real quick. So we have, Carlos knows how he can calculate the amount of interest earned on an account in smaller increments than 1 full year. He would like to determine how much money is in an account each month that earns 5% annually with an initial deposit of $300. He starts by considering the amount in the account each month during the first year. He knows that by the end of the year, the account balance should be $315, since it increases 5% during the year. So I want to look at these input values first. If we're looking at how much money you have monthly, what should these input values be?
1 through 12.
1 through 12. So this is at 1 year, you're at 12 months, right? So I want to emphasize that while this is month 1, we're going to say that this is 1 month out of 12 months. 2 months out of 12 months. So on and so forth. So it's a part of the whole. And since at the end we're talking about 1 year, we want to make sure we denote that this is month 1 out of 12 months, month 2 out of 12 months, so on and so forth. So start with number 1 and number 2, talk about it in your groups, and I'll come around, and once we get to a good point, we'll talk about it.
Really quickly, because I just thought about this, and I probably should have thought about this earlier. How in the world did Carlos go from $300 to $315 if it's increasing at 5% during the year?
I have no idea. That confused the crap out of me.
That's a good idea. Let's talk about this whole thing first. So, what does it mean to, first, let's talk about what is this talking about, an initial deposit of $300?
That's the starting.
That's the starting point, right? Good. So, kind of following up to Mr. Kenny's question, he's earning 5% annually. So how can the money be
Pay
going
attention.
up? He's earning 5%. Multiplying, okay, so what would he be multiplying?
0.5.
0.5. We say 0.05? Or
0.5.
0.5? Okay, so is 0.5 the same as 5%?
Yes.
Do we all agree with that?
Yes, that's,
So remember that 5% is out of 100%. So for,
Fit out
what is it?
of her. Isn't that, is 1 you fit out of her?
Yeah, that's 50%, good. So I was gonna get this, it's out of 100%. So if I had 50% out of 100%, that would give us 0.5. So what would 5% be?
0.
0.5.
0.05. Okay, so this is another good question. So now we have 5% is 0.05. But if I multiplied a number by 0.05, would it get bigger or smaller? It's gonna get smaller. So how is he increasing money if it would get smaller multiplying by?
Because you add 5% to the 100% he already got.
Yes, you add 5% to the 100% he has.
Oh,
So
okay.
when you are earning 5%, that means that you already have 100%, which is the same thing as 1. And when you add 5% to that, you are adding that 0.05. So in reality, there's this 1.05. That's what it means to earn 5%. Good. So with that in mind, now let's think about 1 and 2.
And also, do quickly check, we said we're gonna multiply, is 3 times 1.05, or is 300 times 1.05 315? Let's check and verify that before we move forward.
Yes.
So McKay says yes, Alan, did you check?
I checked and it gave me 15 when he said it, we're adding it, yeah.
Did you try the 1.05 or the 0.05?
I didn't.
So remember, it starts at 100%, then we add 5%. Caroline, did you get the same thing? Linnea? Cool. Okay, so we want to recognize, right, and I'm glad that Donovan remembered this, we talked about it last year, you always start at 100%, then you're adding that 5% on top, okay? That's gonna be important for what we do next. Think about your homework as well. I haven't collected the homework yet, even though I'm going to at the end of class, because I want you to use that homework to help you here.